Right. Let me bring up the old notepad once again. Dear me. I've bumped it up to high performance. So please work. So if case switch loops, you know them all. It's not just Skyrim music, you see. It's Jeremy Soule. He's the you know, the audio guy behind Elder Scrolls. I prefer Oblivion to Skyrim. Played Skyrim for 2 days and thought, what am I doing with my life? And went back to Oblivion, so that should be. That's where all the skoomers are anyway. So, yeah, loops, and then methods, arrays, overloading, that's too far, hold on. 2D arrays. What else? What else have we learned? It's pretty much the fundamentals, isn't it? Coroutines. I'm gonna like some Unity, general Unity stuff. Alright, so let's just crack on. So yeah, here is the old Unity interface. You've got your game scene, game window. Fallout isn't better than Elder Scrolls, so I just have to get the bot to take care of that. That troll in the chat once and for all. So yeah, you've got your game scene, and you've got your scene window. Your scene is where you make your game, you know, infinitely expanding universe here. You can add whatever you like, and whatever you make here will be visible in your game. So let's make a cube, and it will appear. If we reset its position, we can see that it's appeared in our game. And if we want to focus on it, we just put our mouse in the scene whilst we've got it selected, and we press F, and it zooms straight to it. This is one I made earlier. You can change the layout to however you like. So if you go to the top right, there's a little button called layout, just click that. You've got a whole bunch of options here. Or you can just drag and drop things, move things around, you know, whatever tickles your fancy. So we've got a cube. Now we can move it around with our little transform buttons. You can move it around like this. If we hold right click, we can sort of do this rotation business here. If we hold the middle click, like the scroll click, we can pan around. Check that out. Combine the two, you can move around an object. It's just getting better and better. So now you can use the Z to move in and out, and with the green one, the Y is up and down, and so on and so forth. You can use Q, W, E, R, T. Yeah, can you do Y? Why not? So you do this to navigate around, you know, transforming, like moving it, rotating, and then scaling. So you can, you know, make it bigger and shorter depending on what you like. You can also use the rect tool to make it move. It's mainly for 2D, but you can use it to move in one dimension. So if you move like this, of course it's not going to do it now, is it? Because I rotated it weird. Let's just reset the rotation. Right, so if we grab this, move it out, moves it only in one sort of way. If we use the scale tool, look at that. Opens in 2 ways. So that's the basics of Unity. Now let's go ahead and start the purpose of the stream, which is C# programming. So we're going to make a new C# script. Delete that. So you can either do this by right clicking in the assets, going to create and then C# script, or you can click the assets drop down menu, go to create and then C# script. So you've got 2 different options there. We're going to call this variables intro. Hit enter. Hit enter again. Open Visual Studio. Or monodevelop if you're that sort of person. But Visual Studio nowadays is a bit more functional. It doesn't crash as often. But if you're working with multiple operating systems and stuff, mono is generally better. But Visual Studio is good if you're just sticking to a Windows platform. So we've got all this stuff. Probably don't need it yet. Just get rid of all of this. Actually, yeah, let's just keep this one bit here. So we've got our class here. And you see this immediately has gone red, this little mono behavior. That's because it's a special thing that Unity's put in order for you to use all of Unity's stuff. So if you wanted to drag a script onto a game object or access anything game object related, you're going to need this. And to access this, you need the actual library that it's contained in. So if we write using at the top and type in Unity engine and then end it with the semicolon, that means, oh, you know, we've got a whole bunch of code in our Unity engine and we want to use it, so we need that. Now you can see monobehavior has gone a little, I guess, changed colour. It's like greenish, turquoise, don't know. But either way, that means, you know, Unity now knows what this means. It's not just a random word called monobehavior, it's actually something that's derived from this Unity engine. Cool. Now, what we can do is start adding some variables. So variables are effectively containers. Ooh, just dropped my Jaffa cakes. Yeah, variables are containers that, you know, have all sorts of data types. So you can have numbers, you can have letters, you can have whole, you know, range of letters and numbers together in like a sentence. You can have sort of on and off values, like true or false values. What else is there? Decimals. Decimals that have more digits. So yeah, and the best way to do this is to define your data type and then the name of your variable, and that says, okay, we need to store this inside that type. So if we make a number, we can go ahead and write int. So if I scroll in here, it'll be easier to see. Right, so int means whole number. It's short for integer. So an integer in maths is just a whole number. It's just in the set of real numbers if you're into maths. And it should turn blue, and that means it's the data type. Now we can give it a variable name. So we can call this my first int, if you like. It can be called anything, so long as you don't change it later on. And if you stop it with a semicolon, that means you've just declared the variable. So you're saying, okay, this now exists in computer memory, but that's it. It doesn't have any value. It doesn't have the value of 0. It's just null. You know, it's nothing. If you wanted to define that, we would have to put an equal sign and give it a value. So it'd say, if we wanted it to have a value of 5, just write 5. Boom, there you go. We have an integer of the value 5. We could change it to 10, change it to 99, you know, change it to like some crazy value. But that is how you define a value. So there's declaration and definition. So this is declaration, this is definition. You're defining something you've declared. And if you wanted to make just a single letter, you can have a char data type. That's short for character. So, you know, one character or something. We can say my first char, so we can declare it in exactly the same way. The only difference here is that the data type is different. So if we wanted to define a value, we can't just put 1, because 1 is an integer, it's a whole number. So because it's one letter long, we need to have what's known as the quotation marks, but the single quotes, because you're only having 1. And then say you want, you know, the letter C, capital C, or, you know, 3 or something like that. So long as it's one sort of element long, it's fine. If you start adding multiple stuff, it's not going to work. It says too many characters in your variable. So it can only contain one thing. Let's not go with that one. Okay, so if we wanted to extend that and have a whole range of letters, or maybe a combination of the two, letters and numbers, as sort of like a sentence, we can write string, and that's really just char but multiple times. So if we say my first string, that's how you declare a string. If we wanted to define it with some values, we need to put equals and then have the sort of double quotation marks instead of the single ones. That means it can contain a whole range of stuff. And now we can actually start writing a whole sentence if we wanted to. That's the classic hello world. Keep it relevant, but start game, you know. Things like that. Yeah, pretty much anything you like in here. You can mix it up, put numbers in there and stuff, whatever you like. And C# won't complain, it'll just throw it all in. You can't write a string without those quotations, so you can't just do this. Because, first of all, it will the compiler will think that you've got two variables, one called hello and the other one called world. Second of all, they don't have any values. And third, because they're not wrapped in here, they're not defined as a string variable. So you need these to store it in a string. If you're only having one, just use these small ones. And if you've got a whole number, then you don't need them at all. You just have the physical number itself. If we wanted to add a decimal, there's two main ones to concern yourself with. Let's say float. That's the one you probably were first introduced to. And let's say my first float, so that's to declare it. What this means, it's a bit stupid, it's that a number can float either side of a decimal point. I mean, some of the things these programmers come up with, I really don't understand it. But, you know, all it means is you can have a decimal. So let's say it equals 1.1, or it equals 1.0, or 44.5, or whatever. As long as you've got that decimal in there, you're good. However, in some compilers, not all of them, if you're writing something like this in a float, it might complain. Even though you've written a decimal, you're like, oh, what's going on here? This is because if you write a decimal, the compiler may automatically assume that you're trying to write a double. So a double is another data type that can be a decimal. So if we just do this now, and then I'll go back over that error in a second. So double, my first double. That's how you declare it. If you wanted to define it, you do equals, and then say, 88.9765, whatever. End it with a semicolon. You can see how this isn't complaining, because it's a double by default, whereas this one needs to be told that it's a float. So it's like a rebel double, So all you need to do that, you just stick an F on the end, and it says, okay, don't treat it as a double, treat it as a float, set it into here, you're all good. Two main differences between float and double. Float is mainly for 32-bit values, and double is for 64-bit. And because of that, it's called double because it's the double the precision of a floating point value. So yeah, in other words, it can hold more decimal places as opposed to this one. This one isn't as powerful. Pretty much in all software development, because nowadays memory isn't so much of a concern in comparison to back in the day. So you're always pretty much told to use a double. However, in programming games, stick with floats unless you need to do something very specific, because they tend to work better and they're less memory intensive, unless you're doing some sort of simulation. But memory is usually a big issue with games, so don't go around, filling up your computer memory unnecessarily. So yeah. So those are the main ones to concern yourself with the fundamentals of computing. So you've got integers, you've got your decimals like float and double, you've got char, which is like a character, and then you've got string, which is a whole range of characters thrown together. Is there any I've missed? I don't think so. You've got all like the weird ones, but for now let's just keep those as they are. And let's make this less crazy. Let's go 88.8, and let's just say this is 99.9. Yeah. Right. We've got these here. Let's zoom out a bit. And then what we're going to do now is add in the things that we deleted earlier. Oh, Boolean. You're absolutely right. A Boolean, bool, is a on and off value, sort of a true or false value, and they're the only values it can ever contain. And how you do that is you write bool, which is short for Boolean, and then you give it a variable name, so my first bool, and then you end it with a semicolon to, it shouldn't be an equal sign there, and you end it with a semicolon to declare it, and then to define it, you do equals, and then you write how it is, so you can either write false, it will turn blue, or you can write true, it will turn blue. If you write true with a capital T, it's not going to work. Similarly, if you write false with a capital F, that's not going to work. It needs to be lowercase, and you can tell it's working because it's now blue. And that can be useful, if you've got a door or something that's closed. If door is closed, and that can be a boolean, then you can change it to true and it can open, that sort of thing. Okay, so those are all the variables to concern yourself with at this stage. Now we're going to print those so that we can actually see what's going on. So let's type in the method that we deleted called start. So if we start writing start, it will appear here. You can press enter and it will just add it in. We'll go over methods later on, but for now, let's just not worry about that. Just assume that in Unity, something's called start is going to run before anything else. So as soon as you start your game, it's going to start this method. Okay. Now let's print all of these one by one using the print method, let's say. So we type in print, we open our brackets, and in here is where we're going to pass in a variable. So let's first type out our integer. So at my first int, and end that with a semicolon, save it. Now let's go back into Unity and wait for it to compile. So the bottom right screen, it's like hovering a little bit, and now it's done. If we click, actually we save our scene first before anything crashes. Let's say live stream scene, and now let's hit play. Your game most likely won't turn red, but mine has. I'll show you how to do that later. So at the moment, it doesn't look like anything's happening. If we go to the console, just next to your project folder at the bottom, nothing's printing, even though we've got this script. So what's going on? Just because you've made your script doesn't mean it's going to do anything. If you look in assets, this is just your folder. So if we right click in here and click show in Explorer, it just brings up your project folder, and this is what you've got. It hasn't actually been put into the game itself. And to put it into the game, we need to drag it onto something, most likely in the hierarchy. So the hierarchy contains all the stuff that's in your scene. So the cube, for example, is this one. Double click it, you can see it's all here. We have a main camera by default, which looks at everything. And we have a directional light by default, which, shows you how bright the scene is and stuff. Okay, let's drag our script